Hey everybody, Mr. Burnett here. I am your chemistry teacher. Some of you are new to my class. Some of you are not. So we're going to play some tunes here for just a second while we talk about balancing chemical equations. So this unit is all about kind of puzzles and kind of math. But yeah, just a little bit about me. I have a master's degree in biology education and a bachelor's in chemistry. I have been teaching here for 3 years. I'm married. I have a dog and a cat. I love teaching, and I was born in Boston, Massachusetts. So if you have any more questions or you want to get to know me better, please send me an email. I'd love to talk to you. All right, so there's a balance in everything. There's a balance in the force. Here's my little baby Yoda down here, but we're going to learn and talk a lot about balancing today. But to start, you're going to need to know 4 words. Now, this image has a lot on it. There's a lot going on here. So you might want to pause this video right now and write some of these things down. I know that there's going to be questions in the assignment for this on this page. This is the word on. That's an O, not a D. So let's just go over them. This is a chemical equation here in the black, okay? That's what we're going to be working with a lot in this unit and really for the rest of the year. So here you see reactants, okay? This is the reactants right here. These are the things that come together to produce something else, all right? So they're on the left side. They're used up. In this case, they're used up. Sometimes they're not always used up, but the big thing to remember is they're starting the reaction, and they are on this left side. The products, these are produced. They're on the right side. So here I'm making water, H2O, okay? Products are the things that are produced at the end of the reaction. My screen's all fuzzy. Here you have coefficients, okay? These are the numbers that we can change. That's really important. You can see here that I have an arrow in front of O2, but there's no number, okay? That's okay. There's an invisible number 1 here. Just like in math, if you have a problem like this, okay, x plus 5 equals 20, well, there's an invisible number 1 out here. We're just ignoring it for right now. So there's an invisible 1 right here. We're just not writing it. So coefficients, these are the numbers that we're going to change today. This is how many of something there are, okay? So there are 2 H2s, okay? Just like on a car, it has 4 wheels, but you have 2 cars, you have 8 wheels. Think of it like that. Here are the subscripts. Subscripts are things we can never change. Once again, a standard car has 4 wheels. That's not going to change. So you have a 2 right here, and you have just a phantom little Heidi 1 right here. Just nothing going on there. It's hidden, but it is there. Okay? So that will never change. Once again, you might want to pause this and take a look at it. So what are we talking about here with balancing chemical equations? What we're really talking about is the law of conservation of mass. That means that matter is not created or destroyed, right? When you burn fossil fuels, it isn't just destroyed. We wouldn't have greenhouse gases if that was the case. When you burn fossil fuels, things are emitted into the atmosphere, and that's where we really have a problem with greenhouse gases, okay? So nothing is created or destroyed, it's just altered. Because of that, you must have the same number of atoms or molecules, I'm going to call them atoms, even though that's not really totally correct, in the reactants. You have to have the same atoms in the reactants as atoms in the products. Okay, same. You have to have the same number of atoms and the same number of products. So let's take a look at this one right here. Okay, well, I have 2 hydrogen here. Okay, so I'm going to put a 2 there, 2 hydrogen right on. How many oxygen do I have? I've drawn them down here, so I have 2 blue circles, or that 2 subscript, okay, so 2. Okay, 2 hydrogen, 2 oxygen on my reactants. Okay. Now my products, once again, I'm following these subscripts. How many hydrogens do I have? Well, I have 2 hydrogen. Okay. Well, how many oxygen do I have? I only have 1 of those. Okay, remember there's a phantom little 1 right here. Huh. here's my confused Mr. Burnett. It doesn't work, right? This can't be possible because in this version, there's an oxygen that is just destroyed. It doesn't exist on this side of the equation. So something must be wrong. Because the law of conservation of mass tells us we must have the same number of oxygen in the products and reactants. Okay? So this is where balancing the chemical equation comes in play. Okay? So here's the same equation. But remember, I can change the coefficients. I'm going to come back to this page a few different times. But the subscripts I can't change. Those are going to stay the same. But the coefficients I can change. How many cars, for example, I have. I can change that number. So here I have 4 H2s. Excuse me, 4 hydrogens. How many H2s do I have? Well, it comes in this little package. It has to come this way because of the subscript. So I have 1, 2, cool. So I have 2 of them. How many O2s do I have? 1, okay. So I have 1. Well, that's perfect because right there's that invisible number 1. What about waters, H2Os? I have 1, 2 of them. So I needed 2 right there. Okay. So what I've done is I've changed how many H2s and changed how many waters I have. I can do that, right? I can change the subscripts. So let's see if it follows the law of conservation of mass, which one more time means the same number of, that's not a hashtag for you Twitter fans, that's a number of particles, I'm just going to put part, in products and reactants. Okay, so law of conservation of mass has to follow the law of conservation of mass. So let's see. How many total hydrogens do I have? Well, I have 1, 2, 3, 4. Okay, so my hydrogens on this side of the equation is 4. What about this side? 1, 2, 3, 4. Right on, 4. Perfect. Good job. Now oxygen. How many oxygens do I have? 1, 2, 2, 1, 2, 2. Perfect. So I have balanced this chemical equation. Another way to think about it is distributing. So I'm distributing this 2 to here, and I'm distributing this 2 to here, but I'm also distributing this 2 to here. So here there are 2 oxygens. Well, this little phantom 1 over here, another way to look at it is mathematically. So if your mind works well in math, it's like distributing here. Let's go with 2. 2, 2 plus 1. Well, I have to take the 2. I'm getting this 2 from my coefficient. I'm getting this 2 from my subscript. And this 1 from my subscript. So I'm distributing my 2. So I get 4 plus 2. And you can see that down here. 1, 2, 3, 4, 1, 2. Okay, let's take a look at another one. Here's another one. Now this time I didn't draw it all the way out. Okay. This time I just am going to look at what they should be. So 1 phosphorus, 2 hydrogen, 1 phosphorus, 4 hydrogen, okay? So I always start by counting what I have. Remember, it's like a puzzle. I can change things around all the time if I want. I can have 20 of these if I want. But I want the lowest number. So how many hydrogen do I have here? Well, I have 2, 4. How many phosphorus? 1. 1. Cool. So my phosphorus, it's good. I don't need to change that. The hydrogen is the one I need to fix. So I'm going to use this blue marker to show me at my second attempt, because this isn't going to work, right? Not going to work. So if I have 4 hydrogens here, well, I need 2 of these. Okay. It'd be like drawing another 2 red circles. Now, why don't I just draw 1 red circle? Well, the subscript is telling me they are always in groups of 2. Always in groups of 2. So 1, 2, 3, 4. Cool. 4. 1, 2, 3, 4. 4. Right on. Okay. So I just added the coefficient because I can do that. I can have as many H2s as I want. Now, I can't do this. I can't just add 1 hydrogen. That doesn't work. Can't do that. because the subscript that we cannot change is telling me that I have to have 2. And once again, this is distributing over, okay? So 2 times 2 is 4. That's one way to think about it. All right, one last one. Okay, well, this is going to be a little trickier because I have an odd number now, and this time I don't have any drawings, okay? You can always draw these things at home, and I really do actually encourage you to do that. All right, so let's take a look here. Nitrogen, nitrogen, hydrogen, hydrogen. I'll do my first attempt in black, okay? So I have 1 here, 1 here. Sweet. I have 3 here, 2 here. Bummer, okay? So my nitrogens are fine. It's my hydrogens I have to mess with. Now, some of these, when you do them, when you mess with one thing, it's going to mess with other things. And that's just kind of the tricky part about this. But I'm going to go ahead and take a look right now at how to do this. So once again, I'm not going to draw it this time because you won't always be drawing them. Eventually, you're going to get so good at this, you won't have to. Okay? So let's see. To make these equal, I'm going to go ahead and put 2 right here. I'm just trying some things. So that means I have 2 nitrogen, 2 nitrogen, and 6 hydrogen. Okay, so I'm distributing that 2. So you can think about it mathematically, where you have a 2, and then you have a 1, because there's a subscript right here, and a 3, and you distribute. So it ends up 2 plus 6, and that's how you got the 2 and the 6. Or you can think about it visually. I said I wouldn't draw it, but I will. Where I have now 2 of these. I'm going to go ahead and say that's my nitrogen. I've been making hydrogen red. Okay. So how did I know what to draw? Well, NH3 is not going to change. The stuff in black is not going to change. I'm just changing how many of them I have. Okay, so if I'm going to match 2 and 6, well, now I have to change the coefficients over here. So I'm going to put a 2 here. That'll solve this problem. Cool, 2, 2, check. What do I need here? How do I put a 3? 3 times 2 is 6. Done. Okay. So if you are confused, please feel free to email me. This is a really important page. You're really going to have to know these things: products, reactants, subscripts, coefficients, as you go through it. Now, when you answer your assignment on this Canvas page, okay, if you're looking at your Canvas page, there'll be my video. The video will be like right here. And there's like a submit assignment button. And then here are the questions. Okay. Well, you're going to click this button. But first, you want to copy the questions. Okay. You can do that by just clicking on it and copying it, or Control-C, or there's different ways to do it on different computers. So copy this first. Whoa. First. Then you're going to click this button. Okay. That will give you, after you click that button, it'll give you like another little page with a text box that you can type into. Well, here you're just going to paste questions. I think I spelled it right. You're going to paste the questions and then just answer them underneath. Okay. So here will be the question number 1 that I wrote. And you're just going to answer them underneath. Okay. If you have any questions about how to submit, please email me. Thank you, B, for being patient with your week 1 assignments. It's been kind of a crazy weekend here in the school. And I hope to get to know you more as we go through the year.